Alright guys, so let's look to start this. So the question states, consider a system H of t. So you can let this box here be H of t, which is some system, right? It's just a system, right? Such that the output y at t, so the output would be on this side, so whatever coming out is related to whatever input x at t. So x at t coming in by the following equation. Okay, so I have y at t here, which is the output. And we have x at t shifted by minus tau. That's okay. So this here is the equation that they state to represent y at t. So they said y at t is equal to the integral from minus infinity to infinity of h of tau x at t minus tau d tau, right? So this is their object here. So you have x at t coming in. It's being changed, manipulated somehow by the system. And then you have y at t at the outputs. And the equation to represent where, however, x at t changes is represented by this equation here, right? So this is the first part. Derive an expression for the output y at t. Every input is a sum of complex exponential given by, right? So they gave you what x at t was, right? And obviously they want what y at t is. So you have to use the equation that they gave us, manipulate it to get the answer, right? So the first part of this, as you notice, we have x at t. The first thing we need to obtain is x at t minus tau. And all that is just wherever you saw t, you just replace it with t minus tau. So x at t minus tau will just be equal to the sum k is equal to 1 to n, i.e. k e to the j k omega naught, and we just replace t with t minus tau. So that's the first part. Second thing we have to do is you have to replace this here with this piece that we have here. So you'll just end up with y at t is equal to the sum minus infinity to infinity of h at tau, and we substitute this piece here. So it'll be a k e to j k omega naught t minus tau, and it will be d tau. Right, so we're going well. So that's the second part. The third thing we do, right? We have to group everything with tau together, right? So we'll look something like this. So we have y at t. So you'll keep this here for now. About the h at tau. Sum k is equal to 1. So we want to do now, we want to split this up to get the two terms. So we have a k e to the j k omega naught t, then multiplied by e to the j k omega naught, and then multiplied by minus tau. So you could put the minus outside here, and the tau here, and the tau. So now we can clearly see we have this in terms of tau, and this piece here. We'll move the integral sign with it also. So now you end up with y at t, and that's equal to sum k is equal to 1 to n a k e to the j k omega naught t. So that is going to then have the integral from minus infinity to infinity h at tau e to the minus j k omega naught tau d tau. Right, so at this point here, we have something happening. This piece of the equation is known as the frequency response, and it's denoted by capital H k omega naught, right? This is the frequency response of the system itself. Whatever frequencies you put into the system will be affected by this here, which is the frequency response of whatever system it is. It affects the magnitude response and a phase response. right? The filter in this case, the first will have a magnitude response. So how it changes the amplitude of each sinusoid, so that'll be the magnitude of each k omega naught. And then I'll have a phase response, which will just be the phase response of the filter, right? So now with that said, we could just finally manipulate it. So while t will just equal to the sum k is equal to 1 to n at a k e to j k omega naught t. And this whole thing here, we could actually place it with h of k omega naught. Right? Just like that, that'll be the final answer. So that'll be the expression for y at t with this input. Right? The last part, in words, explain the effect of the system on the individual complex exponentials comprised x at t. So every individual complex exponential will be multiplied by its frequency response calculated at that frequency. Right? So every sinusoid is sending at whatever frequency it is, and each will have a different frequency response because it's specific to whatever frequency it's by. All right, so that's that. That is the end of the first